The performance conversation has sort of changed around loading over the last year. We're no longer just thinking about it in terms of metrics like DOM content loaded, which aren't really closely tied to the way that users think about when a page is ready. Instead, we're now thinking about three key user moments. Is it happening? Is it useful? And is it usable? Is it happening means, is the user actually seeing something useful on the screen? Are they seeing, a spinner or application UI, skeleton screens? Something to say that, the browser process is actually kicked off, actually showing stuff. Is it useful is, are you actually delivering them value? Are you showing any text content on the screen, any images, any hint that they're going to be able to start using the process? And is it usable is the point when, if they put their finger down on the screen, that they're able to interact with the application. Now, this idea of interactivity is something that we've assigned some targets around. So we say that if you're trying to build a modern mobile web experience, it's good to try getting interactive in under 5 seconds on 3G on an average mobile piece of hardware. Now, in this particular case, it looks like this phone is kind of dead. I'm pretty sure that this person is going through withdrawal symptoms because they're... Unfortunately, although our goals are being interactive in under 5 seconds, the reality is that for most people, we're still not quite there. The modern experience for a lot of our users on mobile is a little bit different. You often end up waiting quite a while for a page to paint any meaningful pixels on the screen. By the time that it does, you're usually waiting on web fonts or other resources, and then it slowly just descends into madness after a while. So when a user navigates to a page, they're usually looking for visual feedback to reassure them that everything is going to work as expected. We're trying to get meaningful stuff on the screen. We're trying to make sure that they're able to interact with our experiences relatively quickly. Now, this is the current state of the mobile web in 2017. The average web page is interactive in about 16 seconds. That's crazy, right? 16 seconds. It's not fully loaded until about 19 seconds. That's like all the busy work of the network is done. The main thread is relatively quiet. And the average web page strips down about 420 kilobytes of JavaScript. Now, a lot of us, again, if you've sat through a loading talk before, you've probably heard that images are a really big problem on the web. I'm going to talk about another thing, JavaScript. So let's expand on why JavaScript matters on the mobile web. So this is a very high-level view of how the network stack in Chrome works. So let's say that your user, types in a URL on their phone. We fire off an initial request to the server. Server returns some HTML. We then have to parse the HTML. We get requests for CSS, JavaScript, images, any other static resources. And then everything that comes down the pipeline still needs to be parsed, compiled, and rendered before we can actually give them a useful experience. Now, on the JavaScript side of things, the reality is that most of us in this room are probably developing our sites and our apps on relatively high-end machines. I see a lot of MacBook Pros in this room, for example. Now, unfortunately, the reality is that the time it takes to parse and compile JavaScript on our high-end machines is often 4 or 5 times faster than it is on average mobile hardware. That means that the JavaScript that we're loading up is often going to take a very, very long time before a user gets it booted up and is actually able to offer, the event handlers and the rest of the experience that you're trying to deliver down to them. One of the things that we as an industry need to shift towards doing is testing more on real phones and real networks. Just a show of hands, how many people here use the Chrome DevTools device mode? So network emulation, CPU throttling, almost everybody in the room. Now that's a great first step, but unfortunately it's not quite good enough. And the reason is that real mobile hardware differs quite a lot from what we offer you with the DevTools. You can have a different mix of cores, GPUs, CPU, memory, battery. There are a lot of things, including packet-level differences for networks, that are going to impact your overall experience. And one of the first things you can do to improve that is if you have a relatively average piece of mobile hardware, at work or at home, you can plug it into your system, use About Inspect in DevTools. We'll give you access to network throttling. You'll be able to get a slightly better feel for what the experience is like for your users. If you don't have access to any of that, thanks to Pat Meenan, we also have access to a whole farm of Moto G4s, a device that we consider to be relatively average, now available to folks. Now, if you go to webpagetest.org/easy today, you'll find 2 or 3 profiles that are pre-configured for this type of modern mobile testing. We've got faster 3G in there, we've got slow 3G, we've got emerging market 3G in there, we've got desktop. And this will give you not just, the results from loading on a real phone over a relatively decent setup for the network, but it'll also give you a lighthouse report. So Lighthouse is a tool by the Chrome team that tries to audit your experience for modern best practices. It also does checks for whether you're a progressive web app or not, but it's not necessarily tied to that. And one of the benefits of having Lighthouse integration in web page test is that it'll give you those modern metrics that I was talking about earlier. So the notion of interactivity and how long it takes before your user can actually tap and interact with your app. Now, when I'm trying to build an experience that instantly loads, there are usually three things that I try to do. The first is only loading what I need for the user experience. This is all about prioritizing loading the code that my users are actually going to immediately use and trying to defer loading other code until idle time, to some later point in time when it's actually going to be useful. If I'm a single-page application, when I'm loading up a route, the site should only load the resources that are needed for that current view. So let's say that maybe you're a static site, maybe you're a publisher or something. Low priority resources like the comment threads, the additional product thumbnails, all of that stuff can be lazy loaded only when it's needed in the experience. You want to really optimize for the stuff that the user is going to immediately need. Now, back to that point about JavaScript, often today we're still shipping down large monolithic bundles of JavaScript. And one approach for starting to break it up is code splitting. So instead of, if JavaScript represents a pizza, instead of shipping down an entire pizza to our users, we're just shipping down a single slice, so just what they need. And there exist lots of good tools for helping us accomplish code splitting today. There's Webpack, there's Browserify, Clojure Compiler, tons and tons of tools. And this is something that we've actually found quite a few different partners, Twitter, Tinder, lots of others, actually improving their time to interactivity by anywhere up to 40, 50%, just by properly breaking up their work. Now, in case you're wondering, well, do I need to code split? I really don't know whether this is a technique I should be employing. In the Chrome DevTools, we recently launched a new feature called code coverage. And the idea here is that you can load up an application, you can record a new profile with it, and we'll let you know, based on your JavaScript bundles and your CSS bundles, what code was actually used, what code was actually executed. So in red and green, we'll show what was used and what was unused. You can click through to any particular bundle, and we'll show you in the sources view at a block level across your source files what lines were executed and which ones were not. In this particular case, this is a photo-taking app that I built, and I actually have a lot of unused code in here that just never gets executed initially because it's to do with image conversion. That's not something my user initially needs when they're just trying to take a photo. So this work can be deferred until a later point in time. In case folks are wondering whether this is a good enough tool to be able to do real-time analysis as well, it is. You can start interacting with other parts of the application, and it'll actually update in real time these bars at the very bottom so that you can see how much of those bundles get used as you go through the rest of the experience. Another tip is that a lot of folks building modern experiences today are writing it in modern JavaScript, ES 2015. We're usually using a transpiler like Babel. Most people are transpiling back to ES5. And the reality is that a lot of modern browsers actually have decent ES 2015 support now. So instead of transpiling back to a much older version of JavaScript, including those polyfills, you can use Babel preset env to only ship down the code that your browser is unable to understand. So just a subset of features that it hasn't yet quite got. And what we found is that it actually can trim down your bundles quite a lot. Now, I'm not going to be able to have time to talk about all of the techniques I use for trimming down JavaScript, but I consider this sort of the ultimate Webpack slide. This is my workflow for trying to trim down JavaScript. It's not just about code splitting, it's also about tree shaking, scope hoisting with newer versions of Webpack, making sure I'm using the right minifier depending on my workflow, transpiling less code. If I'm using Lodash or Moment.js or other types of libraries, using modules that can actually strip back anything that I'm not really using. And this can have a massive improvement to your interactivity, to your overall load times. Another thing that we often think about when we're trying to build modern experiences is what framework should I use? A lot of folks in this room I know are probably going to be using React or Angular or something like that. The bloat of the baseline that you have when you're trying to develop on mobile is going to depend on what abstractions you're choosing, because they're often not free, they often have a cost. That's not to say you can't use, whatever your favorite tool is. It just means that some tools are better written with mobile in mind, and some require you to put a lot more work in. Because if you're trying to get interactive in 5 seconds, and your framework boot up time is taking up a lot of that, you as an application author are not going to have as much time for your application code. You're going to have to split that up into a much tinier chunk. Fortunately, there are plenty of good, lightweight options for mobile today. There's Preact, Vue, Svelte, Polymer. These all have a relatively low, lightweight footprint. They don't take a lot of time to parse, compile, and boot up, and I'm happy to recommend them. Again, you can use whatever you want, but just make sure that you're measuring and applying some of these splitting concepts where they make sense. I also thought it'd be useful to share some of the newer byte-saving techniques that we're using at Google to solve this problem. Some of these stats we literally just got approval for, so I hope that they're useful. As of last week, all of Google's display ads are now served using Brotli compression. And what we found is that that's led to data savings of up to 40%, 15% in aggregate over gzip. This has had a huge impact for us. Compared to good old sort of gzip file compression, Brotli is generally able to save an additional 20 to 25%, and it achieves that by making use of a dictionary that includes lots of common words and syllables across a number of different languages. And it's not just our display ads team that have found benefits of using Brotli. Across the industry, Google Play are now saving 1.5 petabytes of data every single day using Brotli. We're also seeing LinkedIn, Dropbox, other companies also start to see benefits of employing Brotli support. Another new stat to share with you, Google has been heavily investing continuously over the last while in WebP. And I'm now happy to share that we're serving over 43 billion image requests a day using WebP. Now, WebP generally can save you somewhere in the region of 25 to 30% over other methods. If you're okay with sort of lossy image encoding, it's about 26% if you're okay with lossless. But this is something that we're constantly finding as we employ it across YouTube, Google+, Google Play, the Chrome Web Store, Chrome's data saver mode. This is constantly giving us good savings, and we're hoping to continue investing on it moving forward. Now, something that we've been a little bit slower to adopt, but I still think has a lot of promise, are service workers. Now, service workers, people will often talk about them in the context of, they can enable an offline caching experience, they can enable newer APIs like push notifications. In the case of Google Inbox by Gmail, we actually saw a 10% improvement in time to interactive by employing service workers. This is for static asset caching, so things like our bundles. And this means that if a user comes back to Inbox, after the first time that it's loaded, we're able to just load that stuff locally in many cases without having to go back out to the network constantly. And this has led to some nice improvements. On the topic of caching, the next thing that I try to do is cache aggressively, because the fastest network request is a request that doesn't have to be made. Caching in your applications and in your sites should be granular enough that small changes don't end up invalidating large swaths of your site. Now, HTTP caching has got generally good rules out there. There are lots of best practices that have been well documented. Use consistent URLs so that your content doesn't end up getting fetched and stored multiple times. Ensure your server is providing validation tokens to eliminate the need to transfer the same bytes when a resource hasn't really changed on the server. Consider using service workers for sort of repeat visit control over your offline caching story. And then we've got order loading thoughtfully. And this is an area where I think that there's a lot of promise. I don't feel like enough people have quite invested in this area. And we're going to spend a bunch of time talking about this today. So I feel like a user should never be blocked from interacting with important site functionality because less important non-blocking resources are still loading. And so I want you to take a little bit more control over your loading story. But since this talk is called the Browser Hacker's Guide to Instantly Loading, why don't we go and hack Chrome, for example? I don't think this guy is like hacking. I think he's like scrolling through his Webpack config or something. So we're going to dive into some files in the blank source. This is Resource Fetcher. I know that it's a little bit hard to see this code, but this is one of the places where resource prioritization gets handled. And I know people can't see it, so let's zoom in on just one item. Here we've got a special casing for style sheets, scripts, and media, and we're able to assign different priorities based on their different resource types. You see, Chrome has a kind of a schema for the way that we prioritize different resources. Layout blocking resources like CSS or fonts get assigned a higher priority network-wise. Load and layout blocking resources like images that are in the viewport get a medium priority. Async scripts get a lower priority. And if you're wondering, well, why have I never seen this before? Well, first of all, Pat Meenan has done a great job of documenting this. But second, we expose this in the network panel of Chrome DevTools under priority. So if you take a look at the priority column, you can actually get this information yourself for your own sites. Now, if we go through all these different special casings, what if, instead of saying that some resources had a lower priority and some had a medium and some had a higher, what if we set absolutely everything to have a really, really high priority on it? that would solve everything, right? That would just be the best. We could go home today, we could give our users a very custom browser, we could even call it Fluentinium, and we could give it to all of our users on a USB drive. Except that doesn't quite work. See, the original site that we were profiling here, this is the JSConf site, hit first meaningful paint in about 5.3 seconds. With this change, with Fluentinium, where we assigned the priority of everything to really high, we actually regressed. First meaningful paint didn't happen until about 6.6 seconds. The takeaway here is that when everything is high priority, nothing is. I ended up having to go back and actually play around with different resource types in the page, trying to discover what is a late discovered resource, what isn't, and what exactly should we be prioritizing a little bit better. In this case, the CSS and fonts were particularly important to prioritize. So I have this sort of mantra that I try to follow whenever I'm building something, and it's first do it, then do it right, then do it better. And so we're going to do that with this experience. So going back to the way that Chrome handles network requests, we said that there's a point in this phase where we're parsing resources to try to figure out, we're parsing HTML to try figuring out what assets needs to be fetched next. And what can happen with that parser when it hits assets like script is that it can get blocked. And so some modern browsers have got this idea of a preload scanner. Think of it as sort of another parser that's able to peek ahead in the document and discover critical CSS and JavaScript resources even when the parser is blocked. Instead of having to wait until the CSS object model, for example, is completely constructed, we can find and request resources earlier. Now this is great. The modern browsers have actually seen some wins as a result of this. Unfortunately, that takes us to our next problem, which is resource discovery. You see, the dependency trees for many modern sites are actually quite deep. And as good as the browser can get at loading, you as authors of your pages and authors of your apps know a lot more about what is critical to your user experience than we do. And the way that we give you control over that process, over prioritization, is a feature called preload. One of the folks behind that is Yoav Weiss, who's sitting in the front row, so thank you, Yoav, for this. Preload is basically a declarative fetch, which allows you as an author to say that there are some late discovered resources in your page that you think are super, super important, so that the browser is able to load those with a slightly higher priority. Now, the way that you use this feature is if you're declaratively trying to use it, you can drop in a link rel preload tag. You specify the type of script that you're trying to load up, specify the URL for the actual resource. You can also use HTTP response headers to accomplish the same thing. These headers can come in particularly useful if you have a separate performance team that are handling this work rather than you directly yourself. And in the case of things like JavaScript bundles, where, if it's particularly a late discovered resource, if it's something that the browser is not able to detect until much later in the page, we can take requests that are happening all the way over to the right, and we can move them all the way up to parse time, all the way up to the left. And what I've seen in modern applications adopting this is great improvements to their time to interactivity in general. So that's preload. Another thing that we give you are resource hints, the ability to tell the browser or hint to the browser that there's going to be some things that are also important, but they're not really instructions. They're more hints that it could be useful to load them up. So things like DNS prefetch for pre-resolving DNS host names for assets. Prefetch for hinting to the browser that a resource might be needed, but otherwise delegating it to the browser to decide whether it's important or not. Now, the way that I think about preload and prefetch, now this is a very important distinction. Preload is good for resources inside the current page that you know are going to be used by the user. Prefetch is good for future navigations. So if they're going to probably go to other routes at some point in the future and you want to prefetch some of those resources, prefetch is good for that. Preload is otherwise good for the current page. Now, an app that I think makes really good use of a lot of our modern loading primitives is Shop by the Polymer team in Chrome. Now, Shop is an application that uses granular loading to only ship down the code that's needed for every single route. It takes advantage of modern loading techniques to intelligently prefetch resources that are needed for other future navigations. So as we go through the shopping experience, making sure that things like the product pages have got their resources prefetched in advance. And it also takes advantage of things like offline caching so that you're able to offer your users an instant loading experience when they come back for repeat visits. The way that Shop accomplishes this, and this is on average mobile hardware over 3G, by the way, the way that Shop accomplishes this is using a pattern we call PRPL, or PRPL. Purple is a pattern for structuring and serving modern web applications with an emphasis on the performance of application delivery and launch. Now, the idea behind Purple is that it stands for push, render, pre-cache, and lazy load. So we push the minimal code that's necessary for a page or a route to become interactive. We render that initial route. We pre-cache resources that are going to need, so pre-caching using Service Worker, the resources that are going to be needed for future times that the user comes back to this experience, so they're only going out to the network when we absolutely need to, but we're otherwise taking advantage of proper caching and local access to these files so they load up as quickly as possible. And then we use lazy loading to load up things that aren't necessary for the immediate critical user journey, but are going to be useful for later on in that process. Now, Purple as a model is great for achieving a minimum time to interactive, maximum caching efficiency, and overall simplicity of development and deployment. And one of the things we can actually do is take a look at employing some of these strategies across the development of Shop itself. So when we were building Shop, we started off with just serving it down over H2 with 3G. And we got this sort of network waterfall that had this kind of step pattern to it. And we had this period of time at the very start where we've got sort of server think time. It's not really doing a whole lot at the very start. We introduced link-rel preload into the equation. And you can see that everything is now very, very flat. It's slightly different. We've shifted some more of that work into another part of the screen. And in blue, what we can see is the time from first byte to first contentful paint is down to just 3.3 seconds, just from that initial request. Don't have that stepping behavior anymore. Now, unfortunately, we still have all of this idle time at the very start, where we could actually be doing something useful to make sure that the user experience is loading up even quicker. And the solution to that, one solution to that rather, is HTTP2 server push. Server push eliminates idle network time between the server sending one response to the client and waiting for the next request. Now, looking again at the network stack and the way that we try to process this, the server is able to use think time to push ordered critical resources to the client, typically your CSS and your JavaScript bundles. So by the time that the think time is over, there's a good chance we've already sent all of the required critical resources back to the browser, so that they're already in the push cache that can already be used by the browser. So the idea is, at the same time that I'm sending down my initial request for my HTML, I'm also able to send down all of these resources that I know are critical to the user experience. And that can save me round trips instead of having to go back and forth between the client and the server. If you're wondering what this looks like, so this is an example using Node and Express. We're just setting some of our HTTP response headers here. We're setting our preloads for our H2 push. This is something you can accomplish using PHP. You can accomplish it using other languages. But in terms of the impact that this had on Shop, is we get a very, very different timeline. We've still got a little bit of a cost at the very start, a tiny bit of a cost. We're still spending about 800 milliseconds in the initial request. But we've actually managed to save, at this point, a ton of seconds off of our overall loading time. We're able to get interactive in just a few seconds, much, much quicker than we were before. We're able to fill up that server think time intelligently. So we're using H2 push. I haven't shown it, but we're also using prefetch for future navigations. And it sounds that like H2 push is maybe kind of a magical solution for filling up this time and saving us a bunch of work. But unfortunately, it's not quite that straightforward. You see, one of the major things that people often do wrong as soon as they discover HTTP2 server push is that they start thinking to themselves, well, hey, I have all of these static resources that my page might need. I can just configure every single one of them to be pushed down on all pages. And the main reason that's bad is caching, because there's a good chance that some of those resources are going to be in the browser cache after the user visits the first page. And unfortunately, HTTP2 server push is not as cache aware as we would like it to be. Now, ideally, the solution to this is some sort of Bloom filter, a cache digest of sorts, that would be able to beacon back to the server what contents are in the user's cache so that we don't overly push resources when we don't need to. Now, there is sort of this notion of a cache digest over in spec land that's still being noodled on by folks. It hasn't been really implemented by any browsers. But thankfully, there's a workaround for it that we can use in the meantime. And it's using Service Worker. So we combine H2 server push with our Service Worker, which will allow us, in addition to offline caching, I'll explain this, It tries to avoid that downfall of server push where we're pushing too much stuff down that may already be in the cache. So on first load, the browser makes a request to the server. The server pushes down the critical resources. It pushes down the document. The document gets scanned by the browser. It knows what to request. But oh, you've already pushed those resources, so they don't need to go back out to the network for them. On the next load, when the user comes back to the experience, we've installed the service worker at that point. And the page doesn't even have to hit the server at all. It hits the service worker. And so we're able to load those assets locally. This avoids one of those server push gotchas. And service workers are not necessarily the only way to work around this problem. I have seen some people investigate using cookies to also track what's in the user's cache and beaconing that back and forth between the server. But I've found service worker to be a relatively low friction way of accomplishing this type of pattern. So push versus preload. Push is able to cut out an RTT. It's useful if you have service workers, or at some point in the future we have that notion of cache digests. But it doesn't really have quite the same level of prioritization or cache awareness that we would like. Preload allows us to move resource download time closer to the initial request. It's cross-origin. It's got load and error events. It's got content negotiation support. In general, I found preload to be a relatively low-friction thing to experiment with. H2 push does have a lot of gotchas. It does require an amount of experimentation and understanding of those gotchas before you ship it to production. Now, I just wanted to show, with our service worker employed in this experience, when a user comes back, it's not just that workaround for server push that we have helping our loading experience. Because most of our resources are now coming directly from the local disk cache, we're able to boot up this experience and get it useful for our users in just a few hundred milliseconds. You can actually see, I know that it may be a little bit small, but this is loading from our local cache, and I'm actually able to see meaningful pixels in about 50 milliseconds. It's kind of amazing. So if you want to try shipping an instant loading experience today, use the platform. Take advantage of the network loading features that browsers like Chrome offer. Now, there are a ton of server push rules of thumb that have been documented by some folks on the Chrome team and lots of other folks in the community that are in sort of the web performance space. Try to avoid, pushing too much stuff. Try to push things in evaluation dependence order. Do use some mechanism to track what is inside the client-side cache. There's more information available in this great doc at bit.ly/h2push in case you're interested in these gotchas. Jake Archibald recently also wrote a really great article where he talks about some of the difficulties he ran into with H2Push. Now, if you're trying to employ strategies like Purple and you're building a new application, you might wonder where to get started. If it's a single-page app, I'm happy to recommend Polymer App Toolbox or the Preact CLI. Both of these have support for the Purple pattern right out of the box, and you can go and check them out. So we've been talking about the Purple pattern and this one demo app. But I also wanted to talk about an app that we had the privilege of working on in production, and that's Twitter Lite. I love Twitter. It's kind of like group therapy where nobody ever gets any better, but it's a great app. And they recently actually completely revamped their mobile experience. They shipped it as a progressive web app. This is, Twitter is a company that have about 330 million active users, 80% of who are on mobile. And with this progressive web app, they were able to accomplish something like 1 million daily loads from the home screen. But that's not what I'm interested in. I was actually really impressed to see that they were able to get this application interactive in about 5 seconds. This is a React and Webpack app, by the way. When Twitter started writing this new version of their application, they weren't in a great place performance-wise. They were getting interactive in about 15 or 16 seconds. Overall load was occasionally taking anywhere up to 30 seconds. And so they started looking at the Purple pattern for some inspiration. And so let's start off with push and preload. Their infrastructure was not able to support H2 server push, and so they wanted to take advantage of preload and some resource hints to at least get them a little bit better in the situation they initially had. First thing they took advantage of was DNS prefetching using link-rel DNS prefetch. That's an attempt to sort of resolve domain names before a user tries following a link. And they found that actually led to an 18% improvement over their entire load experience, because Twitter ends up connecting to quite a few different CDNs for their content, for their static assets, for all of that media that you see. The next thing they did was employ link-rel preload for their critical bundles in their application. That led to a 36% improvement in time to interactive. Moving on, we get to render. Now, making sure that we get pixels on the screen as quickly as possible. Now, Twitter is an application that is very media heavy. As you scroll through your timeline, you are probably going to run into lots of pictures, lots of animated cat GIFs, videos, lots of things like that. And all of that work needs to be loaded up. Twitter ended up finding that request idle callback, this browser API that helps you schedule work when there's a free period of time at the end of a frame, allowed them to see a 4x improvement in render performance just by using it to defer the JavaScript, the loading of images that are below the viewport using JavaScript. Another thing that they ran into was they found it was a little surprising that in many cases they were actually shipping down high-resolution images to users when they didn't need that. They switched over to only shipping down images at the exact dimensions that were necessary for the Twitter Lite experience, as well as introducing a brand new optimization pipeline for their images to make sure that everything was properly encoded as well as it could be. And that took them from sort of image decode time on many images being anywhere up to 400 milliseconds all the way down to 20. Now, if you were trying to ship an instant loading experience with images that you want to load up relatively well or efficiently, I would try to adopt some of these ideas. So choose the right format, do some research around whether you can get wins from WebP or other image formats, size your images appropriately so that you're not having a too expensive amount of image decode costs, adapt intelligently using the picture element, compress carefully, prioritize your critical images, lazy load images that are not necessary for sort of the initial user experience, and take care with tools because we do know that some of our tools don't do a great job of stripping out the metadata that aren't necessary in there. Something I was impressed about with the Twitter Lite experience was they also introduced a data saver mode where they blur out images and videos in the experience so that we don't actually load them until you, the user, say, well, I actually really want to look at this media. So if you tap on it, it's going to go and make that request off. But otherwise, by default, not including all of those requests in your overall waterfall, they're able to see up to a 70% improvement in their load times using this technique. Next up, we have precache. Twitter took a very incremental approach to adopting service workers. They started off with sort of a Noop service worker that didn't really do anything. Then they looked at static asset caching for the Twitter emoji that you see when you're trying to reply to people, as well as their JavaScript and CSS bundles. They eventually ended up adopting the application shell pattern for their UI caching. And what this did was, rather than it taking 6 seconds for their JavaScript and experience to load on a good 3G network, pre-cached, it took only 1.5 seconds once those assets were already in the user's cache. That's a 75% improvement. Next up, we've got lazy loading. So remember, we said that it took somewhere in the region of 15, 16 seconds for Twitter to initially get interactive. And that was because they had 3 large JavaScript assets, which totaled over 1 meg in size. That work on an average phone took anywhere up to 5.5 seconds just to parse and compile, which wasn't great. So they adopted support for code splitting using Webpack, took advantage of vendor chunking, just making sure that libraries and other abstractions that were necessary across lots of different routes were in their own chunk that could get cached. And what they found was that taking this approach to sort of intelligently caching things a little bit better, intelligently splitting up their work, meant that it only took 3 seconds to load up the JavaScript necessary for their experience. We've got case studies available on the entire Twitter Lite experience that we had from both the Twitter team and our team, in case you're interested in learning more about that. Now, one thing that the Twitter Lite experience didn't really run into was web font loading as a problem. Now, 68% of sites on the web load at least one custom web font, and so having a web font optimization strategy can end up being a pretty critical piece of your overall performance loading strategy. A lot of us are familiar with this notion of FOUT, so a flash of unstyled text, where you can try loading up a web page and you'll see text initially, and then it jumps around and starts getting really jittery and janky once the web font finally loads and finally kicks in, which is a kind of weird, a really weird loading experience for users. Another is FOIT, so a flash of invisible text, where the browser can end up completely blocking showing any content at all until your web fonts are loaded. Web font loading experts recommend having a good comprehensive web font loading strategy as being pretty critical if you want to make sure that you're rendering these custom fonts as well as you can be for your end user experience. This is a really great visual from the Zach Leet blog. He's got a really great blog post that talks about having a comprehensive web font loading strategy. And I wanted to quickly touch on some of the items in there. So we talked about preload today. With web fonts, you'll often end up first needing to parse your HTML, parse your CSS, before you can actually get to going and fetching your fonts at all. And so similar to the idea that we saw earlier with our JavaScript bundles and prioritizing those a little bit better, with preload, we can shift this work all the way up to the other side of the waterfall. We can make sure that those fonts are getting fetched much, much earlier. Now remember, that's not to say that every single asset in your page should be getting preloaded. The stuff that you consider critical to your user journey that's probably not going to get discovered until later on is the stuff that you should be preloading. Now again, if you're going to use preload for this stuff, you can use link rel preload to specify type font, as type as font. You can also use a HTTP header to accomplish the exact same thing. I was actually quite surprised digging into the HTTP archive to discover that most of the sites that are adopting support for link rel preload are using it to preload their web fonts. This led me to discover that Shopify were preloading web fonts, and this led to a 50% improvement in their time to text paint. One of the benefits that this also had for Shopify was that it completely removed their flash of invisible text completely. So consider that. Another thing that we recently landed in Chrome 60, was better control over font performance using font display, a new CSS property for font face. The idea here is that you as an author control whether you want to block, swap, whether you want to even say that web fonts are a completely optional thing, so that, if the browser is not able to load them quickly, why should it load them at all? Why should it use them at all? Now I'm going to touch on optional because I think that optional in font display is kind of one of the most powerful things that we've brought to the platform lately. The idea here is that if the browser is not able to quickly load a web font, we will continue using the fallback. If that web font is able to complete its request, we'll put it into the cache, and so that the next time that your user comes back to that experience and they come to the page, they will get that custom web font. It's just something that won't be as jarring to their overall experience. We've also got the CSS font loading API in case you need better control over manipulating CSS font phases, tracking download progress. We've got a lot of blog posts that talk about some of these concepts available. Lots of web font loading tips available to you. This is a quick cheat sheet. My colleague Monica wrote another great blog post about this stuff if you want to check that out. But in general, have a web font loading strategy. Now in the last few minutes, I thought it'd be useful to talk about the future. I think one of the big opportunities that we have for loading on the web is going a little bit more progressive. So instead of this idea of waiting for all of the content in our HTML files to fully be fetched before they can be processed and rendered, what if we were able to fetch things in chunks and then start to render them on the screen as the rest of the experience starts getting landed on our side? One of the things that enables that is the Streams API. This is one of the fastest ways that you can serve content. Blog-like content benefits from this quite a lot. And if you pair this together with other loading features like service workers, you're actually able to get an incredibly competitive loading experience off the back of it. We're able to relatively well beat things like server-side rendering or service worker rendering with client render. Jake Archibald has got some great blog posts about this. Another thing that we're exploring is the idea of trying to align a little bit better with browsers like Edge around how we handle CSS in Chrome. So Edge does this thing where it will block the parser until the style sheet has finished loading, but allow content above the link tag to render. What that means is that style sheets are able to load in parallel, but apply in series. And it takes style sheet behavior a little bit closer to being like script source. That looks a little bit like this. It's the idea of like having a link rel tag right above the content that you want to start rendering to your user. A big thank you to Pat Meenan, who's been driving a lot of this work in Chrome. And one other thing that I think we have a huge opportunity around, and I'm hopeful that some folks in this room will explore it at some point in the future, is the idea of us getting a lot more data-driven with our loading. I think today we make a lot of guesses. We eyeball traces. We make a lot of guesses based on waterfalls of what makes sense for our users. I'd love to see more folks using analytics data to drive their decisions, to drive their loading experience. Using things like the analytics APIs we've got available to decide what should be prefetched, what should be preloaded. Using machine learning, using TensorFlow to make those decisions about what makes sense to eagerly get in advance for your users. I hope that loading is a topic that a lot of folks in this room care about. I know that lots of folks are standing, so hopefully you do care about this topic. But performance is sort of this continuous game of measuring for areas to improve. It's not just this one thing that you do once and then say it's done. So I hope that you found some of the loading techniques and ideas in today's talk useful. If you have any experiments that you're working on in this space, please feel free to share them. But that's it for me. Thank you.